What's up everyone? This problem is called Prefix Max and is from Codeforces, and here's what it says. You're given an array of n integers, a, 1, 2, and so on until an. The value of an array is the sum of the maximums of each prefix of the array. More formally, the value of an array a is the sum from I1 until in, and on each iteration we are going to get the max from a1 up until ai. For example, the value of the array 1 to 1 is max 1, max 1 2, and max 1 to 1, which would be 1 2 2. That would be 1 plus 4 equals 5. You can choose two indices, one I and j, and swap elements ai and aj. This operation can be applied at most one time. Find the maximum possible value of the array a after at most one operation. Input. The first line of the input contains a single integer t. t The value of t is between 1 and 100 inclusive. This is the number of test cases. The first line of each test case contains a single integer n, which is between 2 and 50, the length of the array a. The second line contains n integers, um, a1, a2, and an, uh, and these are each between 1 and 10,000, I think that would be, yeah, the array A. So, yeah, so let's see. This means that for each test case, output the maximum possible value of the array A after the swap has been performed. So let's look at an example. Let's say for the example presented, we're going to have four test cases. So for the first test case, we're going to get the length n, for the meaning we're going to receive 5 elements. So the task is basically find the maximum value of this array given this definition or with this definition. So um, let's look closely at the example. Here, as you can see, it says for the first test case we can swap a1 with a4. Okay, so let's see, a1 is 2, and to get the array an 8 4 would be 1 2 3 4. So we would swap 5 with 2 in order to get the array 5 1 4 2 3, which has a value of max 5, max 5 1, and so on up until we get the result of 25. For the second test case, the current value of the array is max 5 plus max 5 1, which would be 5 plus 5 equals 10. If we were to swap a1 and a2, a would be equal to 1 5, which has a value of max 1 plus max 1 5, which would equal 6, meaning the best option is not to perform a swap. Perfect. Okay, so this problem is basically asking us, and you might be able to tell just by these notes alone. Um, we're basically being asked to first find the value of the array given the um, this suffix condition, or I don't know how to call it, which is basically we're gonna iterate over these values, and on each iteration we have to um, find the largest non-value up until that point. Meaning, let's say we are going to iterate over this value, over these values, and we start with 2. And because 2 is the only number we know up until that point, that is the largest number as well. So if we perform the computation max, the result would be 2. Then we would get to know 1, and to perform the max computation, the result would still be 2, and so on and so forth. And we can do this, no problem, but the task is to find the maximum possible value of the array A after at most one operation. So we are able to perform all that this is saying is basically we can swap two numbers um, at most one time in order to get the maximum value. So two cases can happen. Either we can be given the best possible combination, or we will have to perform one swap. So how do we go about this? Well, basically, if you think about it, in order to get the maximum value for the array, uh, we have to uh, get the largest number in the array, and then we will have to put that largest number at the beginning of the array, or in the first position. Why is that? Because think about it. That's basically what they did here. They took the largest number, put it on the first position, and in that way, as we iterate over the array, on each iteration, when we perform the max calculation, that will output the largest value every single time, as you can see here clearly. And we can do this literally with every test case for this problem. So hope that makes sense. If not, let me show you how to go about it. So let's jump into it. Let's see. First, we've gotta take the input t, which is between 1 and 100. So that can be a simple int t, and this would be the number of test cases. Okay, so we can do something like this in order to iterate um, that certain number of times and receive those test cases. Then we're gonna have to take the line, the value of n, which is how many integers there are going to be on this array. So let's see. We could do something like this. Let's say we define n up here, and then on each test case, we would just take the value of n for that particular test case. And now, here I could do a couple things. First, I could literally do the array or the vector, and we could store the numbers there. But if you think about it, we don't really care that much about all the values. We just care about finding the largest value out of these n integers. So following that logic, I don't have to strictly um, store all the n integers as long as I just find the largest one. So in that case, I can do something like this. Let's say I do something like value, and we could initialize to 0, for example, maybe, because all the values are going to be larger than that. Okay, and then I'm going to do something like, sorry, not that, max value. And all I'm going to do right now is basically I'm going to iterate over the n values and we're going to find the largest one. That's pretty much it. So let's see, we do something like this, and this should do. Okay, now for we're basically going through each of the n values for this particular test case, and now what we're going to do is first we take the value, and then we have to compare it. Particularly, we do something like if this keeps opening my bad. Something like it's if the current value is larger than the max value, then we're just going to assign the max value to this new found largest value. Okay, so that's how we find the largest value out of this array. Well, quote unquote array, but out of these n integers. And now that we have that, uh, here's another tricky part of the problem, or at least it got me confused at first. It says that you can choose two indices, I and j, and swap elements ai and aj. And now, here's the wording. Initially lets you to think that in order to solve the problem, you have to literally perform the swapping. But if you take a step back and think about it, all we care about is what will be the maximum possible value after the operation, after at the most one operation, if applicable. So we don't actually have to perform the swapping. We can just sort of like perform or compute the result that doing the swapping would result into by following these defined steps. Hope that makes sense. And what I literally mean by that is, as I said, we have to find the largest value. We put it in the sorry, we put it at the beginning or at the first position of the array, so to speak. And from there, every single iteration would result on that largest value. Hope that's clear. And once that's the case, or we can be certain that that will be the or because we can be certain that that will be the case, we can compute the maximum possible value of the array by just taking the max value times n, which would be the number of elements in the array. Then that's basically how we solve the problem. Hope that makes sense. So to do that, we can do literally something like max value times n, and that's it. We don't have to do the swapping. Uh, so that got me confused at first, but hopefully this helps you a bit. And now we can actually run this. Let's do it. And as you can see, it has compiled. So let's give this a go. We can test this. Okay. And here we got 25, 10, 9, 14. 25, 10, 9, 14. Okay, looking good. So let's actually submit this. Prefix Max. There you go. So let's roll. It's running on test one and it has been accepted. Awesome. As about the complexity of this, as you can see, the main task is really to find the max value out of these n values. So we can say that the value would be O of n because we have to literally go through every one of the n values in order to find the largest one. So that's how we solve the problem. Hope that helps.